I'm going to talk to you today about robots. Actually, most of the robots will be at the end, so some of you will see a little bit of a clip of the Pepper robot. There's a bit more in a similar vein, mostly towards the end. I'm going to talk about AI, and I know many of you here would say, well, come on, that's just a marketing term, machine learning, genetic algorithms, let's talk about the real stuff. I'm only going to talk about these things in quite a shallow way, so I'll prepare you for that now. Broad but shallow. I'm not going to talk about the detail too much. I have got a couple of slides that have code on, though. So there is code. Um, One of them is a trick, as you can see. I'm going to talk a little bit about what is sometimes called the singularity, and essentially the point where the computers get as intelligent as us, or maybe a bit more intelligent. So we'll talk about those things. I am on social media, if that's your persuasion. So you can find me Martin Hamilton on Twitter. I'm using the hashtag BCS event. If you use that hashtag, you'll also see there's lots of other BCS events pop up on there. So it's quite commonly used to amplify BCS activities online. If you aren't online and that strikes your fancy, if you try to connect, there is a nice Wi-Fi network here that you can connect to for free. Just go on here, and obviously, you must use your real name and identity. You couldn't possibly make up an identity to get online because that would be wrong. Very wrong. So, who am I? I work for a company called JISC. We run the JANET network, amongst other things. So most of you, if you've been to university or been to college at some point, you've probably used the JANET network, connecting you to the internet, connecting colleges and universities to each other. We run that. We also run things like EduRoam, which is like BT Open Zone for universities, just mail mailing lists, and a whole bunch of other stuff. So if you've been a student in the last, what would you say, 30, 40 years, probably, you encountered those things. And we do a whole range of kind of shared services, deals for services and content, and advice and guidance. And where I'm from today is probably mostly in the advice and guidance territory. So it's like, well, what is all this stuff that people keep talking about? What could it mean for me? And my own role in JISC is I lead our future and emerging technologies team, where we actually get to try stuff out, and then we try and produce how-tos, hints and tips, advice and guidance, and this kind of thing. Sometimes those things turn into actual new products and services as well. Something we're quite excited about right now is brain-computer interfaces. So this is my colleague Sue had. That EEG headset she's wearing costs about 250 quid. It's good enough. It's not a clinical grade EEG headset, but it's good enough that you can fly a drone with it. So you might say, oh, yeah, okay, this is just some kind of toy. You can see your brain waves in an iPad app. That's very cute. It's very interesting, actually, though, as well as being able to fly a drone with this. It's very interesting to see the areas of the brain that are active before and after. For instance, you ask somebody to translate something. So we demoed this to a conference full of university vice chancellors recently. We said, we buttonholed one of them and said, okay, do you know any foreign languages? Oh, may we? Okay, right. Let's do some real-time translation. Let's watch your brain light up. That was absolutely fascinating. So this is just an example of something that it's not quite available in shops yet. Well, it kind of is if you know where to look, and yes, it's available online. I think it was the product of a Kickstarter. But things like this that will probably have quite a transformative effect on us in the future. Imagine you're going for a job interview, or imagine that you're preparing for doing something like this. Well, okay, where do I start? Actually, being able to do a little bit of self-analysis and reflection, finding out what's going on in your own brain, actually is pretty interesting. So that's the kind of stuff that I do as a day job. Now, I'd be very happy to talk about any of that. I should say, do feel free to break in if you've got any comments or questions. So if you think, oh, what is this bloke talking about? This guy's an idiot, or I'd really like to know more about X, Y, and Z. So do feel free to break in. It's not a problem at all. I'm going to talk really about the stuff I'm going to cover today in 3 chunks. So the first chunk is how we got to artificial intelligence, and you can see here I've put machine learning in here because I recognise that I'm talking to a more sophisticated audience than, let's say, the average person in the street who would read about artificial intelligence. We're talking about machine learning, and of course, if you are into this stuff, you'll know that there are layers and layers and layers beyond that, which we'll talk about a little bit as well. But first off, I wondered if anybody has ever seen this before. So this is a BBC broadcast from, it was about 1951, 52. So the title of this, if you can't see it at the back, is Can Digital Computers Think? So we tend to think about artificial intelligence as quite a modern thing, as quite a new thing. But actually, all those years ago, there were people thinking about it. But I wonder if anybody would like to hazard a guess about who wrote this.
Alan Turing.
Very good, yeah. So maybe you've seen the Alan Turing archive. So if you go to turingarchive.org, it really confounds your idea of Alan Turing as this very secretive person. He did stuff in the war, but we don't talk about that. And actually, he must have been a little bit of a public persona to be doing a program with the BBC about digital computers. And obviously, this is in His Majesty University years. So very interesting. But people have been talking about this for a long time, so it's not perhaps as new as maybe it sometimes feels. What I think is really fascinating, though, is that now the technology that you might use to do artificial intelligence has actually democratized to the point where you can do it with something as cheap and cheerful as a Raspberry Pi. So I've got a video here that I did a little while back. I didn't bring my squishy brain today. When I do these talks, I often bring a squishy brain along to throw around the room. But the point being, the Raspberry Pi, which costs like £25, is powerful enough to do some quite interesting things. So you might think, oh, I need a super-powered computer, I need a supercomputer. But actually, you can do a surprising amount with just a little bit of technology. So I wonder if you can hear this.
So isn't that
We asked it to recognise the objects that we put in front of it.
Ballpoint.
Ballpoint.
Let's try something that the computer brain ought to recognize. Mouse.
Brilliant. So I don't know if you caught what we're doing there. The Raspberry Pi is actually, it's got a camera plugged into it. Okay, it's got a speaker plugged into it, so it can talk to us. And just getting it to recognise a few things, and it's using a piece of software from Google called TensorFlow. And that's a thing, literally, it's a thing that you could just go out and do. The software is free, the Raspberry Pi is very cheap. And, compared with the cost of a PC, for instance, a powerful PC, it's next to nothing. This TensorFlow software from Google is what made that magic happen. So Google's TensorFlow software is becoming the de facto standard for doing artificial intelligence applications. It's open source, it's got loads and loads of contributors, and as you've seen, it will run on something as simple and cheap as a Raspberry Pi. So we asked TensorFlow to tell us what those objects were, and it said, oh, that's a ballpoint pen, that's a mouse. How did it do that? Well, very helpfully, lots and lots of people have created something called ImageNet. And ImageNet is another piece of open public data, in this case, not code. And ImageNet has classifications for about 14 billion different pictures. So you can come along, you can present it with a picture, and say, right, okay, what have we got here? Is it a pen? Is it a cup? Is it a mouse? So when we talk about artificial intelligence recognizing things, so something like a self-driving car. How does it know that's a pedestrian? How does it know that's a cat running out in front of the car? Well, this is kind of where it all starts, really. A big public database of images, machine intelligence from Google lets us put it all together, and we can run all this stuff on a humble little Raspberry Pi. And that means that can run off a battery, by the way, and there is an even smaller one. So that means that you could take the AI that would let you recognize those objects and embed it into something very small. And why would we want to do that? Well, you know, sensor networks, self-driving cars, there's lots of interesting applications where you don't necessarily want to have a honking, massive, great PC, say, in the boot of your car, chuntering away as you drive around. But how does it actually learn? Go on.
Can I ask a quick question just
Yes,
about
yes.
that application, the TensorFlow? So does the software then access the internet to access the images, and then there's a comparison between what's installed images and the camera?
So my little demo there is all self-contained on the Raspberry Pi. You don't need even a massive memory card to download the whole of ImageNet. What I didn't say is Google also trained an ImageNet model for TensorFlow, so you can literally just download it. You don't have to train the AI. So when I show you this little video, you'll see an example of an AI being trained. So think about self-driving cars. How does it know that that's a child stepping out in front of the car? This is Google's DeepMind learning to play Breakout, and maybe some of you know DeepMind has been playing video games. It's spent quite a lot of time playing video games, so it's like a kind of bored teenager maybe. So they go, right, yeah, okay, let's get on to the next one. If you watch this, after it's been trying to figure out how to play Breakout for a while, it susses perfect strategy. From this point on, you will always whoop your ass at Breakout. You can never beat it. And by the way, once you've seen this, you will know how to win at Breakout every time. So watch this. But it has no idea what the rules are. It doesn't know that there are particular things that it should be doing. Maybe all it knows is if your game lasts for a long time, you're doing something right. So keep doing what you did before because it seems to be working. So all it knows really is that it can move the paddle around. And the longer the game, the more successful it's been. It doesn't know how to play Breakout, but it knows how to win at Breakout. It doesn't even know what Breakout is. It just knows that if it moves that paddle around, the game lasts a long time. We're winning. So when we talk about artificial intelligence, we have all these ideas about computer brains that you can communicate with and interact with, perhaps in spoken English or what have you. This has none of that. It's not conscious. It's in no way sentient. There's no kind of true intelligence there at all. It's just recognizing patterns and responding to particular patterns. How could we take that and use it somewhere that maybe a bit more useful? I mean, Breakout's great. You could spend a lot of time playing Breakout. That would be fun. But maybe you could use it for something a little bit more real world. So this is a video from the Udacity self-driving car project. And Udacity is a kind of online education provider. It's a spin-out from Stanford. This is a video that they've made of the AI recognizing the types of objects in a video. So literally, somebody went around and shot a video of just boring driving around town, and they fed it into this machine learning model, which is saying, okay, if you can read these, that's a car. And you'll find, so there was a truck over there, and it finds road signs, it finds bikes, it finds pedestrians, and so on. But the real point of this is part of a course to teach you how to become a self-driving car engineer. So it costs about, I think it's about $3,000 or $4,000, and you have to commit several months of your time to do this. And the way it works is you work with industry mentors, so you can learn to be a self-driving car engineer working with somebody from BMW, maybe Jaguar Land Rover or something like that. It's a very different model to, let's say, going away to university for 3 years to learn how to do something. This is very much hands-on. But there we are. The techniques that it's using there are just the same techniques that we saw earlier on to play Breakout. Except now, instead of playing, oh, it does look a bit like a video game, doesn't it? But instead of playing Breakout, we're figuring out what these objects are. And if you go through that course, and by the way, all of the materials are online, they're free, they're open access. You could start to move from recognizing things to saying, well, do you know what? I reckon they might move a little bit unpredictably, so what do I do? What do I do if that bike or that motorbike suddenly unexpectedly switches lane? And so there are people right now all over the world who are learning how to build self-driving cars using exactly the same techniques that we saw a minute ago. People who are learning to play Breakout. So I thought that was really fascinating. It gives you an insight into what the, if you like, what the computer sees. The computer doesn't really see, the computer knows perhaps that there's an obstacle just to the right. You know, a cat has run out in front of it or whatever. It doesn't know what a cat is, but it knows that if that thing happens, perhaps we want to take evasive action, perhaps we want to slow down or stop. And like I say, this is all out there, this is all open source code, videos that show you how it works. So a bit like the Raspberry Pi, if you're there thinking, yeah, what is going on here? How do I get to grips with it? How do I learn more about it? There's an awful lot that's out there that you can simply download, videos you can watch, tutorials you can work through that will help you to understand what's going on. And ultimately, I just love this video, so I've got to play it whenever I get the opportunity. But this is SpaceX with the reusable rocket boosters. I think this is all of those principles taken to the nth degree. You've got, I think it's a 40-story tall building equivalent rocket. You know, they don't look, because there's no other objects for scale typically. You don't realise how big these things are when you see them on video. This thing's just been up into space, and it's landed on a barge in the middle of the ocean, which is barely bigger than it is. Do you think that a human being was there with a joystick going, right, no, left a bit, right a bit, slow down? No, that's all happening, under computer control, and there's a machine learning model, like the one that we saw recognising the obstacles, potential hazards in the driving video. So they're going, well, actually, do you know what? keep going, and left a bit, right a bit, faster than any human could. So I think this is really fascinating. Would you trust your life to it, though? So Elon Musk wants to use this technology essentially as a very rapid transit mechanism. He wants to put a capsule on top with people in it. He wants to, fly you to Australia in an hour and a half or whatever. Would you do it? Maybe. This is where you say, well, I'll let you do it first. See how you get on. I won't play that again. It is very good. So I said there would be a couple of slides with code on. This is the simplest neural network that I could find. Neural network, so what underpins all of this. And they've cut a few corners, and you probably couldn't do anything useful with this. It's a very simple neural network that just takes these triples in and does a bit of classification on them. You can find out lots more about this if you go to this guy's website. But what he tried to do was to say, look, these concepts all sound great, but actually when you start to pick away at them, there's lots of libraries and frameworks, and it's all very intimidating. If I just wanted to learn about how a neural network works, I understand that they're the underpinnings of the AI that people keep talking about. Where do I go? How do I just take some baby steps? So this is about the simplest neural network, and this is written in Python, so it's very accessible. You don't need to go off and maybe learn a whole new language for it. That doesn't get you very far, but it does give you a little bit of insight into how these things work. So literally, you can go up to this guy's blog, and he's got worked examples that get progressively more complex. So you can start out with something very, very simple. It's just about recognizing patterns of noughts and ones, and you can go from there to something that's really quite sophisticated. At JISC, what we're trying to do with this is to use it to help people who are at our universities and colleges, and we're using a technique called learning analytics, which is all about taking the data that comes out of people's interactions with systems. If you're a student, you take a book out of the library, or you click a link in a virtual learning environment, and all of these things generate a little data trail, a data resource. Well, what can we do with those? If we put those into a machine learning model, maybe we can say, hey, do you know what? People like you, on the whole, carry on the way you are, you're going to do really well. But also, perhaps in some cases, people like you, you're going to fail, actually. And there's the real difficult challenge is, how do you best communicate that? And actually, it's probably not directly to the student. We probably don't make a little notification on the student's phone to say, hey, you're going to fail. You know, come on, work harder. What we probably do is we notify their tutor. We say, you know, you really want to have a word with this Martin guy. He's just not trying enough. He's not working hard enough. Maybe there's some problem. And we think that we've got about 40 universities and a couple of colleges that are working on this. It's looking very promising. We think that we can probably take it a little bit further and include things like environmental data. So I don't know how warm it is for you on your side of the room. Here in front of the projector, it's pretty toasty actually, and there was a bad smell in the room earlier on. Maybe there's some noxious gases swirling around. The light levels in here are pretty good, but in a lot of places the light levels maybe are somewhat lacking because they've got mood lighting rather than, let's say, task focused lighting. So there's all these kind of environmental factors that we could throw into the mix as well. That's basically what we're trying to do is to improve that predictive model by throwing in more data. So the more data we've got, the better kind of decision making we can do. And we think ultimately that might well lead to a situation where everybody pursues a slightly different pathway as a student, because you have strengths and weaknesses, and sometimes you need a particular thing reinforcing. And actually, with a bit of AI on the side, we can have a sort of AI tutor, if you like, which says, you know, I'm going to work with you. A bit like, has anyone played with the app Duolingo to learn a language? So if you use Duolingo, it actively tries to reinforce the areas that you're weak on. So we think that there's probably a transferable model. So that's what we're doing. But actually, really interesting stuff is not about recognizing things, which is what I talked about before. It's about creating things. So let's create some stuff. This is one of my favorites right now. This is another piece of open source. It's actually a research paper. You can grab the paper, you can grab the code, and play with it yourself. And what this guy's done is he's got a little app here that lets you draw a picture, and then you can say, okay, make me a cat that looks like that picture. And the AI goes up and makes a cat in the style of that doodle. Also makes, goodness knows why they chose these particular things, handbags, shoes, and buildings. So you can do all four. And if you draw a monster, then you get a cat monster, or presumably a shoe monster. I've not tried that. That doesn't exist. That never existed. That's just created by the computer in response to this picture. And it's been told what a cat looks like. So it's had lots of pictures of cats, which it's trained itself to recognize a cat. Here's another example. This is from a site called Deep Dream Generator. Some of you might have seen Google's Deep Dream visualization technology in the last couple of years. It's had lots of press. Deep Dream Generator takes a picture, like a painting, this example here, and another picture, like a photo of a dog, and now you get a dog in the style of that painting. And it's worth pausing for a moment to think about that. So literally any two pictures, X in the style of Y, and it doesn't take very long, it just takes a few seconds to gender away and go back with boom, X in the style of Y. And that has been produced for us by a computer. That never existed. It just created it out of thin air for us. And taking it one step further, that's called artistic style transfer. Taking it one step further, why not do that with videos, right? So, you know, that would be fun, wouldn't it? So this is a research team at University of Freiburg in Germany, who've done exactly that. So, would you like your would you like your Ice Age or whatever other video clip it is in the style of? Would you like this in this style? This could be a filter coming to your phone before long, you know, when you take a picture or a video.
So is that done on a per frame?
I think so. I can't remember the details of this one, I'm afraid, but I will share the slides, and there's a link here to the paper that shows you how they've done it. And yes, Darth Vader too. I think Darth Vader and Jungle Book mashup could be particularly interesting. There we go. So there are many questions here, of course. You know, would you want to do this in the first place? Is one of them. There are some reasons why you might want to. How much computing power does it take to do this? This is not going to happen on your Raspberry Pi. Let's be brutally honest. It needs a bit more horsepower. But this gives you a little bit of an idea of what's possible. From the same guy who had that code snippet, there's a thing he did which I was quite tickled by. He fed his machine learning model the complete works of William Shakespeare, and now he can say, okay, I'd like something a bit Shakespearean, please, and it will come back, and it knows that there are characters, and it knows the characters' names, so it will create Shakespearean quotes attributable to actual characters from Shakespeare's plays. So, I don't know, here's King Lear. Oh, if you were a feeble sight, the courtesy of your law, your sight and supple breath will wear the gods. It's good stuff, isn't it? I actually think that sounds quite Shakespearean. I don't understand quite a lot of Shakespearean plays. And I look at the text, I would need someone to translate it for me completely. And I think that would fit in perfectly. Actually, I think unless you're a Shakespearean scholar, you might well be fooled into thinking that actually is a quote from one of Shakespeare's plays. Then, I did say there was another slide with code on. So this is, and you might want to hold on to the side of your seat here. This is a machine learning model that's been trained with the Linux kernel source code. So it now produces Linux kernel source code stuff. And I don't think it compiles right now, but that could be part of the process, could be to say, well, keep generating it until you come up with a version that compiles. I don't think I'd want to run it in my kernel, you know, but we often talk about robots and AI making people's jobs obsolete and this sort of thing. And I think if you work in technology, then it does gives you a little bit of a pause for thought when you see something that really does look like a piece of Linux kernel code. And you know, there are certain stylistic traits that a Linux kernel module has that you'll just see in all those modules. There's particular quirks and even typical spelling mistakes and snarky comments that will pop up. And this looks quite plausible, really. It's nonsense code. This might not compile, but next month's version probably will compile, and it might do something as well. Maybe we'll actually reach a point where we say, well, this is the goal that we're aiming towards. Make us some code that we don't care what it looks like, how it works. This is the outcome that we want. Go on. And how does that all work? I said I was going to be broad but shallow, so this is my broad but shallow interpretation. Remember the very short bit of diagram code. This is meant to be a little diagram that explains how we might feed in some patterns to what they commonly call a discriminator network. This is a neural network model, a machine learning model, which recognizes things. So it might be recognizing that we've drawn a 0 or a 1 or what have you, or it might be recognizing a roadside. It might be recognizing that there's a barge in the middle of the ocean that we want to land our rocket on. And that will either say, yeah, got one, or it will say no. So this is the bit that's probably the most well established right now. Think about those self-driving cars. And actually, if you buy a new car right now, you'll often find that your car can recognize speed limit signs. It has some cameras, it's doing a little bit of processing. So this stuff's quite well established. What's not so well established is the other half, the generator network, which produces something, perhaps from input like white noise, literally random input, produces something. Let's say it's just like a squiggle. I don't know what that is. The discriminator network takes that and says, no. No, try again, that's definitely not a 0. This thing biases its algorithm just a little bit and produces a new squiggle, which maybe is just a little bit closer to that, until the point where the discriminator network says, yeah, you got it. And that's the very simplified underlying principle behind all that generative AI that I showed you just now, is two neural networks competing with each other. So one makes things and the other one is already trained to recognize the things that it makes. You've done a good job there, or try again. What can we do with that? Again, an example from my world, we're working with a company which is generating teaching and learning materials that are of a high standard from, let's call it, the random scribblings that you might have. So if you're working as a teacher or a lecturer, you haven't necessarily got someone with you who understands how best to present material so that your learners can understand it. So these guys have built an app which does that for you. So you can feed it Word documents and PowerPoint slides, and it will. And this sounds like magic, right? But then so did some of the other stuff I showed you. And it will take the content that you give it, and it will smarten it up. It will extract key concepts. It will even do things like construct multiple choice quizzes for you based on content. It's really fascinating. So we were recognizing things. That was kind of the first part. We were generating things, and we've hopefully seen today one or two things that you've not seen before. Lots of interesting things you could make. What's next? Well, I did say I'd have some robots as well. So, has anybody actually met the Pepper robot in real life? Anyone? No? So I think you'll be seeing a lot more of Pepper, because the company that makes them has now sold about 10,000. And in Japan, the equivalent of, I don't know, EE in Japan, which is called SoftBank, uses them in all their stores as a greeter. So if you go into a SoftBank store, one of these will glide up to you and, konnichiwa, and have you thought about renewing your mobile contract? We have some very good deals right now. Maybe it's not how you imagined that you did first encounter a humanoid robot, but there we go. Nestle are planning to introduce them. You can see this is one of Nestle's fancy coffee pod shops. They're planning to introduce them in their upscale coffee pod outlets. So, anywhere that has a fancy shopping mall, chances are you'll be seeing Pepper in it. If not, this coming year, then probably quite soon afterwards. Also, I think it's very interesting when you look at this one. They have this kind of tablet embedded on their chest. That's a stethoscope, right? Yeah. So, how are you feeling, and how long have you been feeling that way? And you can see where this might be leading. The number of times that you maybe go to see the doctor, you spend a lot of time in the doctor's surgery describing your symptoms to the doctor. when something like this could be capturing them for you. I'm not saying this is necessarily a priori a good or bad thing, it's just a thing that might happen. If you were paying attention earlier on, you might have seen a little video clip here, but I'll just cue this one up again. So this is Pepper the robot going to visit the Financial Times. They gave Pepper a bit of a hard time.
No rush, take your time to close the curtains and remove any obstacles around me. Say, okay, when you think it's good.
Okay.
So, I am the robot. You are the human.
Thank you.
And this is the beginning of a beautiful story. I like humans. Humans are so cute.
What once existed only in the mind of Isaac Asimov.
We'll stop there, but I love that line that humans are so cute, and you could sort of picture it saying, "I could keep one as a pet" or something like that. Pretty neat things, humans. Obsolete now, of course. So Pepper the robot, it was kind of like they were actually talking to it, and it actually understood them. It's a little bit of a swizz because actually Pepper follows a script. And if Pepper can understand what you're saying, then it knows which bit of the script it's in and what to do next or what to say next. So it gives the appearance of being a lot more intelligent than it really is. But it's still quite fascinating to see how far we've come. And like I say, that is a real thing. It's an actual product. It costs several $1,000s, and you will see it. You will see it increasingly popping up. There's also a bigger version called Romeo. And this is where it starts to get a little bit intimidating, because Romeo is nearly the height of a grown adult. And Romeo is meant to work as a care worker. So let that sink in. Here's another sort of robot. Does anybody know about the Amazon distribution centre in Colville? Does anybody here work for Amazon? Oh, that's good, so I can say what I like about them. So if you think about Amazon, think about robots. I don't know. Here's this rather cute Danbo robot that's big in Japan. It's made out of Amazon boxes. Quite a cute, unthreatening thing. Actually, Amazon's warehouses are starting to fill up with robots, and this is how they work. They bought a company which makes these pretty amazing little orange robots.
You've clicked buy, and your online purchase is complete. But Betty Bot's work is just beginning.
Don't ask me why it's called Betty Bot.
She's a Kiva robot at Quiet Logistics Fulfillment Center.
So they bought Kiva, did they?
That's right. So
Behind
this
every
is Kiva
online
robot.
store is a warehouse full of merchandise. One is Quiet Logistics, where there are 1.5 million items stored.
So
It's
this is a
Betty
bit like
Bot's
an
job
Amazon
to
warehouse,
retrieve your
right?
purchase, and she can do this faster and more accurately than any human ever could. When you buy something online, your order enters the Kiva database. The software locates the robot
So there's the
closest to your
robots
item
moving
and directs
around.
her to retrieve it. Using a network of barcodes on the floor, she navigates the 300,000 square foot warehouse, tunneling beneath the pods as she moves throughout the grid. When Betty Bot reaches her target, she slides beneath the pod and lifts it off the floor.
So this is the genius part. Once you've seen it, you go, "Oh, why didn't I think of that
She
before?"
carries your purchase through the warehouse streets. This area is called the Human Exclusion Zone, where no human may enter. There are 100 Kiva robots operating autonomously on the floor.
So I'll stop there, but you kind of get the idea. So there are 45,000. Well, actually, I did this slide a little while ago. There's probably quite a few more. Well, there were 45,000 of those robots in Amazon warehouses around the world. What they do, they patrol the human exclusion zone, and they bring the shelving to the humans who pack the stuff. So when you order something from Amazon, might not be true right now because they are hiring lots of people to work in the Colville distribution centre. So I don't think the robots have quite taken over Colville yet. That might come. they bring the shelving to a small number of humans who are in a sort of cage, and a human can reach out and grab the item that you ordered to put it in the box to ship it off to you. And that's how it works. So there's going to be a lot more of that. But that's not all. And this is a piece of active research right now. It's called the Amazon Picking Challenge. And the Amazon Picking Challenge is something that a lot of robotics and computer science teams at universities around the world are very excited about, because they want to design the algorithm and the robot arms that will be able to pick out particularly awkward, fragile objects, things that are quite hard to hold because they're squishy maybe, and basically eliminate that human picker. So the human picker right now still has a job in the Amazon warehouse. When they crack this, and it will be useful in all kinds of other scenarios, but the immediate one is that Amazon won't have to employ so many people in their warehouses. So that's their kind of prime driver. But having figured out how to do this, these technologies developed for the Amazon Picking Challenge will have all kinds of applications, not just teddy bears and pairs of scissors to go in your Amazon box for your Christmas delivery. And that brings me on to this could be quite a downbeat section, so I don't want to end on a low. I have got some other material to kind of lift the mood a little bit, but we talked about self-driving cars, right? They've been in the news a lot in the last couple of days because the government's doing a big program of investment. Well, think about this. There's 350,000 registered taxi drivers in this country. In the States, there's 3.5 million truck drivers. And all these people are literally, their livelihoods are threatened by these technologies that we've been looking at. And I think this is really, it's a very stark reminder that technologists tend to work in the domain of the technology that excites them, interests them the most. So, there's a problem to be solved, like the picking challenge. I want to figure out how to do this. I want to build the robots that can do this. I want to write the code that can get that object, however awkwardly shaped or fragile or squishy or whatever. I want to be able to write the code to do that. I'm going to make my name for myself doing that. I feel that I've done something worthwhile. But at the same time, if we leave those people behind, they're not going to be too pleased about it. And they're going to turn to technologists and they're going to say, I'm going to find where you live and I'm going to come after you because, I was doing quite well for myself until you came up with all this self-driving vehicle stuff or, warehouse packing robot stuff. So increasingly we're hearing about a new job, a new type of job, the Chief Ethics Officer. And I think in this kind of context, it's really hugely relevant. If you say, okay, I'm going to introduce this technology which literally puts hundreds of thousands or millions of people out of a job, well, what am I offering them in return? Is there a sort of vague promise that they're creating as many opportunities as we take away jobs that exist right now? Are we actually actively doing something, or are we just saying, yeah, technology is great, you should learn more about it? There's a course you can go to about digital skills at your library. Go off and learn about digital stuff. Perhaps we could actually be a bit smarter about it. The other thing that's very relevant here is we're not necessarily talking about blue-collar jobs, we're not talking about white-collar jobs. There are lots of things that people do in all walks of life, all levels of society, that are susceptible to the kind of automation that I've been talking about today. So it doesn't matter, you might say, well, I'm an accountant, what relevance could this possibly have for me? Well, actually automating a lot of processes that you might currently, you're very well remunerated to carry out those processes, automating them might just turn out to be a little bit easier than you realise. So where does that leave us? Are we going to have, what we've seen in San Francisco is people actively lobbing rocks at big tech companies' shuttle buses. So if you get the Google bus in San Francisco, there's a good chance someone's going to chuck a rock at you and maybe smash the window of your bus and probably chase you home and say, I'm going to run you out of town. That's not a desirable outcome, is it? perhaps we can be smarter. But at the same time, we've got things like Brexit going on, where there's really a kind of big pushback against globalization, all of the aspects of globalization that we tend to take for granted. The fact that you can order something online that will be in your house a couple of days later, even though it's come all the way over from China. All of these things that we take for granted right now. Technology doesn't respect those national borders. Technology doesn't respect geopolitical differences. So another facet, I think, of the ethics debate actually is what technologies are simply out of the box? Where is the genie out of the bottle? And all that stuff I showed you about machine learning, classification, and generative AI, it's not simply the case that people are doing it. The people who are doing it have openly shared all of their stuff by and large. So it's very hard to say, oh, well, actually, we're not so sure about that anymore. Could you put that away now, please? Because we want to go away and we want to have a serious think about it. You can't uninvent it now. So it falls upon us to say how we're going to make the best possible use of it, and how we're going to make the outcomes, the bad outcomes, not as bad as they could potentially be. So I didn't want to end on a low note, but all of that I think has to be said. But at the same time, as I said before, with technology, we tend to have a very optimistic outlook on it. We're going to learn how to make an autonomous drone. Someone might do something with that drone that we subsequently wish they hadn't. But, we made the autonomous drone. They might attach a chainsaw to it, for instance. So this is a real thing. This is something that's in Finland. A drone with a chainsaw. What could go wrong? We could say, actually, do you know what? Perhaps we don't want to get involved with that. But we tend to be quite optimistic about how the things that we create will be used, and sometimes perhaps we need to think how they could be misused, and that's where that ethics element comes in. I want to leave you with it could be almost a swan song for humanity, or it could be an amazing bit of composition, a song that's composed by an AI. So this actually mashes up elements of human music. It's got a little bit of Brian Eno in it. It's got some human musicians. So I'll put that on in a minute. I wanted to reiterate though before I finish, a lot of this stuff, if you want to get involved with it, if you want to learn about it, the resources are out there. There's free software you could download. A lot of the research papers that describe how people have done the things that I showed you, they're open access. You can go and grab them and you can play with them. We do our own little bit about trying to demystify these things. So we have a website that has some of our own investigations and guidance. But there is an awful lot to take in. So if you do think, oh yeah, I want to learn more about this, then be prepared for the fact that it's not just neural networks. There's convolutional neural networks, adversarial and recurrent neural networks. There's lots of different flavors of these things, and it's not simply a matter of, I want to learn more about X. Many, many flavors of X. But let's have that song. Let's go out with a song. So this is called Mr. Shadow.
It's summer cycling through it's wrapping those wings around. Those wings around. It's summer cycling through it's wrapping those wings around. Those wings around. It's
That's made by Sony's research lab, by the way. So maybe that's the moment. Wouldn't it be handy if you were a record company and you didn't have to deal with those pesky artists because they weren't paying and stuff? Wouldn't it be much more convenient if you could just push a button and out comes a new chart-topping hit?
I thought Simon Cowell had already done that.
So I don't think they're quite there with Mr. Shadow yet, but I think Mr. Shadow's it just as a sort of harbinger of what direction you can take these things in. It's very interesting. And that's me. So I'll shut up now. But if you've got any comments or questions, I'd love to hear them. Thank you very much. Thank you for having me.